Have you ever wondered how your smartphone can do so much? From streaming your favorite shows to navigating you through traffic, it's a marvel of modern engineering. Or how your car knows when to brake. The precision and reliability of these systems are crucial for our safety. It's all thanks to microchips, those tiny squares of silicon that power our modern world. These microchips are the unsung heroes working tirelessly behind the scenes. These little marvels are the brains behind countless devices, from the simplest toys that entertain children to the most complex spacecraft exploring the far reaches of our universe. They are everywhere, making our lives easier and more connected. Without them, our world would look very different. Imagine a day without your phone, your computer, or even your car. It's almost impossible to fathom how much we rely on these tiny components. Microchips are essentially miniaturized circuits packed with billions of microscopic components. These components include transistors, resistors, and capacitors, all working in harmony. These components work together to process information, make calculations, and control the flow of electricity, enabling our devices to function. They are the silent workers, ensuring everything runs smoothly. From the moment you wake up to the time you go to sleep, you're interacting with devices powered by these incredible inventions. Your alarm clock, your coffee maker, your fitness tracker, and even your television all rely on microchips. They have become an integral part of our daily routines, seamlessly blending into our lives and making everything more efficient and enjoyable. Imagine a bustling city shrunk down to the size of your fingernail. That's what a microchip is like. Just like a city has different areas with specific functions, a chip has different components that work together seamlessly. These components include transistors, logic gates, registers, memory units, a control unit, and an arithmetic logic unit, or ALU. Each of these plays a vital role in processing information and carrying out instructions. Think of transistors as the city's electrical grid, logic gates as traffic signals, registers as mailboxes, and memory units as libraries. Transistors are the fundamental building blocks of microchips. They act like tiny gates that control the flow of electricity. By switching on and off billions of times per second, transistors allow chips to process information at incredible speeds. These tiny switches are made from semiconductor materials which have special electrical properties. The most common semiconductor used in chips is silicon, a readily available and highly versatile element. The development of the transistor in the mid-20th century revolutionized electronics and paved the way for the microchip revolution. Logic gates are like the decision makers of a microchip. They receive input signals from transistors and, based on pre-programmed logic, produce an output signal. There are different types of logic gates, each performing a specific logical operation, like AND, ORgan, and NOT. Registers, on the other hand, are like tiny storage units that hold small pieces of information temporarily. They're essential for holding data that the chip needs to access quickly while performing calculations or executing instructions. Think of them as the chip's short-term memory. Section 5. Memory units, remembering it all. Memory units are like the libraries of a microchip, storing vast amounts of data. Just as a library categorizes and stores books for easy retrieval, memory units organize and store data so that it can be quickly accessed when needed. This data can range from simple instructions to complex files and applications. There are two main types of memory: RAM, which stands for Random Access Memory, and ROM, or Read-Only Memory. Each type of memory serves a unique purpose in the functioning of a computer system. Understanding the differences between them is key to grasping how computers manage and utilize data. RAM is like a scratch pad, used for temporarily storing data that the chip is actively using. This means that any data stored in RAM is volatile and will be lost when the computer is turned off. However, its speed and efficiency make it ideal for tasks that require quick access to data, such as running applications and processing information in real time. ROM, on the other hand, stores permanent instructions and data that the chip needs to boot up and function properly. Unlike RAM, the data in ROM is non-volatile, meaning it remains intact even when the computer is powered down. This makes RAM essential for storing firmware and other critical instructions that are necessary for the basic operation of the computer. These memory units are crucial for storing everything from your operating system to your favorite apps and files. Without them, your computer wouldn't be able to function. They ensure that all the necessary data is readily available, allowing your system to run smoothly and efficiently. Whether it's loading your operating system, running applications, or accessing files, memory units play a vital role in the overall performance and reliability of your computer. Section 6. Control Unit and ALU. The heart of the operation. In the intricate world of microchips, the control unit and the ALU are the unsung heroes, working tirelessly behind the scenes. The control unit acts as the brain of the microchip, fetching instructions from memory and directing the other components to execute them. It deciphers the instructions and sends signals to the appropriate parts of the chip, ensuring that each task is carried out in the correct sequence. It's responsible for coordinating all the activities within the chip, ensuring that everything runs smoothly. Without the control unit, the chip would be like an orchestra without a conductor, with each section playing out of sync. The ALU, or Arithmetic Logic Unit, is the math whiz of the chip. It handles all the calculations and logical operations that the chip needs to perform. It performs arithmetic operations like addition, subtraction, multiplication, and division, as well as logical comparisons. These operations are fundamental to the chip's ability to process data and make decisions. Together, the control unit and ALU form the central processing unit, or CPU, the heart of any computing device. The CPU is what allows your computer, smartphone, or any other digital device to function. It processes the instructions that make your applications run, your games play, and your videos stream. Without the CPU, none of this would be possible. It's the powerhouse that drives the digital world. The price of progress? Why chips are expensive? Creating these microscopic marvels is no easy feat. The high cost of microchips stems from several factors, including extensive research and development, complex manufacturing processes, and the use of expensive materials. Developing new chip designs and manufacturing techniques requires massive investments in research and specialized equipment. The manufacturing process itself is incredibly intricate, involving hundreds of steps and demanding extreme precision. Furthermore, the materials used in chips, such as silicon wafers and rare earth elements, are costly to source and refine. Chips in action, from phones to spaceships. Microchips are the unsung heroes of the modern world, powering a vast array of devices and industries. From the smartphones in our pockets to the cars we drive, chips are everywhere. In consumer electronics, chips enable smartphones, laptops, televisions, and gaming consoles to deliver incredible experiences. In healthcare, they power life-saving medical equipment, from pacemakers to MRI machines. In aerospace, chips control everything from navigation systems to life support in spacecraft. Measuring clock speed and core count. When we talk about chip performance, we often refer to clock speed and core count. Clock speed, measured in gigahertz, indicates how many instructions a chip can process per second. The higher the clock speed, the faster the chip. Core count refers to the number of processing units, or cores, within a chip. Each core can handle its own tasks, so a chip with more cores can perform multiple tasks simultaneously, leading to faster processing speeds for multitasking and demanding applications. The future is tiny. Advancements and innovations. The world of microchips is constantly evolving. Researchers and engineers are constantly pushing the boundaries of what's possible, developing even smaller, faster, and more efficient chips. Advancements in nanotechnology are enabling the creation of transistors and other components at the atomic level. New materials such as graphene promise to revolutionize chip performance and energy efficiency. The future of chip technology is full of exciting possibilities, with the potential to transform our world in ways we can only imagine.